Siemens SPS2.
Audio.
In today's world, energy is the backbone of all economies and supports every aspect of social and cultural life throughout the world. The demand for this commodity is steadily rising. Siemens aids by providing products that support this growth. The plant in Richland, Mississippi manufactures and designs a full line of products, including circuit breakers, transformers, and voltage regulators, and is a local distributor for Siemens surge arresters and insulators. Here, the latest technology, combined with the economies and precision of a streamlined state-of-the-art production facility, allows Siemens to make quality products which are used in thousands of installations worldwide. The SF6 circuit breaker has proven to be one of the most important units in electrical power systems. The protection, stability, and continuity of service of the entire system depends largely on the efficiency of its operation. Because of this, Siemens circuit breakers designed and manufactured to operate within the ANSI IEC standards and protect electric utility systems by interrupting fault currents and switching line, load, and exciting currents. Breaker overview. Each breaker consists of 3 pole units mounted on the breaker frame. A pole unit is 2 SF6 insulated bushings with either porcelain or composite material mounted on a grounded aluminum housing containing the interrupter. The individual pole units are connected to the SF6 pressure switch by the way of copper tubing and fittings under the linkage cover. A rupture disc is provided on each pole unit to protect the breaker in the event of overpressure. Up to 4 current transformers may be mounted at the base of each bushing. The interrupters consist of a moving and stationary contact assembly mounted inside the pole unit housing. Electrical connections to the bushing's terminal plates via the conductor rod insertion into the contact cup on the moving and stationary interrupter support assemblies. Each interrupter is mechanically connected to the spring operating mechanism through an operating shaft assembly, lever, connecting rod, and horizontal pull rod. The spring operator mechanism housed in the control cabinet is electrically trip-free and contains both the opening and closing springs, its own motor for recharging the closing spring, and the trip and closed solenoid and latches. Within the weatherproof controlled cabinet, a heater provides continuous inside-out temperature differential with space for additional thermostatically controlled heaters when required for low temperature use. Also in the housing are the necessary auxiliary switches, closing and opening spring charge indicators, position indicator, and operations counter. Control switches and relays, cutoff switch, and alarm switch are also mounted inside. Terminal blocks are provided for control and current transformer wiring. Auxiliary tank heaters can be supplied if required for extra low temperature operation. The temperature sensing bulb for the pressure switch extends through the cabinet under the linkage cover. If required by the customer, an optional manual trip mechanism is located on the left end of the control cabinet. Principles of operation. Interrupter. The interrupter consists of 2 separate assemblies, a moving contact assembly and a stationary contact assembly. Each assembly contains a flange, an insulated support tube, and a contact carrier to which the contacts are assembled. Both contact carriers contain plug-in contacts for the bushing leads. When the interrupter is in the closed position, the main current path is through the continuous current fingers, which are parallel to the arcing contacts. Since the continuous current fingers are not arced during an interruption, they maintain low resistance for the life of the interrupter. During low current interruptions, the piston compresses SF6 in the compression volume. When the arcing contacts have parted, gas flows through the heating volume and into the arc, which is contained in the Teflon nozzle and exhaust, through the hollow moving arcing contact and through the stationary contact assembly. This puffer action is sufficient for low current falls and switching operations. During high current interruptions, heat from the arc causes pressure to rise in the heating volume, which closes the check valve. Pressure in the heating volume continues to rise until the throat of the nozzle clears the stationary arcing contact, allowing high pressure gas from the heating volume to flow through the nozzle, extinguishing the arc. Gas trapped in the compression volume after the check valve closes is vented into the tank across the relief valve in order to prevent a decrease in contact velocity during high current interruptions. All of the hot gas and arc products are contained within the pole unit housing. Operation of the mechanism. Basic overview. The basic overview of the operation of the mechanism is to charge the closing spring. The charging shaft is rotated by means of the charging motor and gears. Charging motor turns the shaft, which rotates the shaft through the upper dead center point by 10 degrees. The closing spring compresses, causing the shaft to rotate back and latch at dead center, and now the closing spring is completely charged. By pressing the closing latch coil, the energy in the closing spring is released. As the closing spring discharges, it rotates the charging shaft and the cam plate, which transmits the movement to the operating shaft, in turn closing the interrupter unit simultaneously charging the opening spring. Principles of operation. Spring operator charging the closing spring. With a breaker open and the closing springs relaxed, a switching operation is not possible. The cam plate and the connecting rod are at the lower dead center point. The fixed coupled levers are in the open position. To charge the closing spring, the charging shaft is rotated by means of the motor and gears. The free wheel engages the charging shaft and rotates it as far as the upper dead center point. The charging shaft is then tunneled as far as the closing latch. At this point, the freewheel disengages from the charging shaft. The motor shuts down automatically at 10 degrees beyond the upper dead center and runs down with the gearing. The closing spring is charged and the operating mechanism is ready for a close operation. Principles of operation. Spring operator closing the breaker. Activation of the closing coil disengages the lever and the closing latch. The effect of the closing spring turns the charging shaft. The roller of the lever rolls along the cam and moves the operating shaft. This motion is then transferred to the operating shaft lever that connects the operating rod to the interrupter unit. The contacts of the interrupter unit are then closed. At the same time, the opening spring is charged by way of the operating lever and the spring retaining rod. The opening latch moves along the roller and the latch lever. The roller of the closing damper moves along the cam of the backstop and reduces the residual energy of the closing spring. As the end of the over-travel stroke, the end of the lever will engage with the support latch to lock in place. The circuit breaker is now latched in the closed state. As the closing process takes place, the charging motor is switched on to charge the closing spring. The charging shaft is latched with a charged closing spring at a position about 10 degrees beyond the upper dead center. Repeated actuation of the closing coil is prevented by mechanical interlocking. The closing and opening springs are now charged, and the circuit breaker is ready for an open-close-open switching sequence.
iStock Audio.
Principles of operation. Spring operator opening the breaker. Activation of the trip coil disengages the opening latch via the two latch levers. The bell crank assembly is moved into the open position by the opening spring action on the connecting rod. At the same time, the contacts of the interrupter are moved into the open position by way of the operating mechanism rod. At the end of the opening movement, the kinetic energy is absorbed by the opening damper. The damper serves also as end stop.